Welcome to this explainer. Today, we're tackling a deeply frustrating reality of our modern workflow, AI's built-in amnesia. If you've ever spent hours uploading documents, asking questions, and getting these great answers, only to realize the AI literally forgot everything the very next day, yeah, you're absolutely not alone. So let's dive right in and learn how to fix this by building a persistent, compounding knowledge base called the LLM Wiki. Here's our roadmap for today. We're going to cover the AI memory problem, meeting the LLM Wiki, a step-by-step setup guide, visualizing your knowledge, linting and fixing errors, and finally, some real-world use cases. Section 1. The AI memory problem, and why your AI just keeps forgetting. So, why does your AI always start from scratch? Have you ever noticed that when you ask an AI a question about your documents, it has to do all the work from zero? And if you ask a similar question tomorrow, it's learned absolutely nothing overnight. Every single question starts from zero. Nothing is saved. Nothing compounds. It's incredibly inefficient, right? Now, this standard process you're probably using right now is called RAG, or Retrieval Augmented Generation. And sure, while it works fine for simple queries, think about what it's actually doing behind the scenes. It acts like an amnesic researcher who has to reread all your source papers every single day before answering you. If your question requires connecting ideas across, say, 5 different documents, the AI has to find those exact pieces and stitch them together entirely from scratch every single time. Honestly, that is a massive bottleneck. Section 2. Meet the LLM Wiki, your AI's new persistent memory. Andre Karpathy actually flips the old model completely on its head here. He says to think of Obsidian as the IDE, the LLM as the programmer, and the wiki as the codebase. So instead of searching raw documents every time you ask a question, you have the AI read your documents once to build an evolving, interlinked encyclopedia. You use a program like Obsidian as your viewing environment. The AI acts as your active organizer, and the resulting structured wiki becomes your permanent knowledge base. The best part? You rarely write the wiki yourself. The AI is doing all the heavy lifting for you. When we compare the two systems, it brilliantly illustrates the difference. The LLM Wiki essentially replaces that amnesic AI with a dedicated, highly organized researcher. When you add a new PDF or article, the AI doesn't just store it away for later. It actually reads it, extracts the key ideas, updates your existing pages, and links related concepts together. The knowledge literally compounds. The synthesis is completely done before you even ask your very first question. Section 3. The step-by-step setup guide. Let's look at the folder structure. Let's empower you with a simple, beginner-friendly setup guide using just plain text files and an AI coding agent like Claude Code. Seriously, if you can create a folder on your computer, you can totally do this. First, you'll open a free note-taking app called Obsidian, which works perfectly with plain markdown files. You'll create a main folder, Obsidian calls this a vault, and set up 3 simple subfolders. The raw folder is your source of truth. You just drop your read-only PDFs and articles right in there. The AI reads from it but never alters it. Next, the wiki folder is where the AI actually builds and maintains its interlinked pages. And finally, the templates folder is just there if you want to enforce specific visual layouts later on. Easy, right? Now, the crucial point is how the AI actually knows what to do. And that brings us to the brain of this entire operation, the schema file. If you're using Claude Code, you'll just create a simple text file called claude.md in your main folder. Think of this as your rules document. It tells the AI the core purpose of your wiki, like, say, planning a trip to Japan. It maps out where your raw folders are, sets rules for how pages should be formatted with summaries and citations, and instructs the AI to always consult the wiki first before answering your questions. Section 4. Visualizing your knowledge with the Obsidian Graph View. Let's see what happens when we drop some web articles or PDFs into that raw folder and simply tell our AI coding agent to ingest the new sources. Honestly, this is where the magic becomes real. In the Obsidian Graph View, you'll actually see these beautiful visual nodes connecting in real time. As the AI reads your new travel articles or research papers, it automatically generates structured pages. It'll create pages for specific neighborhoods, separate pages for food, and then actively link them all together. With every single source you add, the wiki gets smarter, and these visual connections grow denser and denser. Because the AI has pre-built all this structured knowledge, let's see what happens when you ask a really complex question, like what neighborhood should I stay at if I want to be close to the best food and still near the major temples? The AI doesn't have to frantically search through raw, unorganized articles anymore. It seamlessly synthesizes data from the neighborhood, food, and temple pages it's already built. It connects dots that were spread across completely different source files, giving you a synthesized, fully cited answer almost instantly. It's like having your own personal expert on standby. Section 5. Linting and fixing errors to keep your wiki healthy. Of course, the AI isn't pure magic, right? It can sometimes miscategorize data or miss a connection. But just like how a code linter checks a developer's code for problems, you can periodically ask the AI to lint your wiki. The AI acts like a structural health checker here. It scans your entire folder to proactively identify broken links, find contradictions between sources, or spot concepts that were mentioned but never given their own dedicated page. It even flags incorrect source citations and automatically offers to fix them for you. This linting process is exactly how you keep your wiki healthy and perfectly accurate as it scales up. Section 6. Real-world use cases and who benefits the most. So, how can you start applying this beginner-friendly AI workflow to your own life today? Well, whether you're a student mapping out complex, really dense study materials, or a researcher trying to synthesize dozens of papers without losing track of your citations, this is an absolute game changer. By the end of a semester, you have a structured knowledge base, not just a massive pile of highlighted PDFs. And it's equally powerful for businesses organizing chaotic meeting notes or lifelong learners tracking their personal book reading lists to ensure they actually retain what they read. Basically, it works anywhere you're accumulating knowledge over time. Now, we do need to be totally transparent about the practical limitations here. This isn't really for massive enterprise databases. This setup runs beautifully on your own computer for a personal scale of around 100 articles or so. And remember, the golden rule of data: garbage in, garbage out. The wiki is only as smart as the high-quality sources you feed it. And crucially, Obsidian doesn't do this alone. You absolutely must have an active coding agent, like Claude Code, running alongside it to act as the programmer building your pages. The days of treating your AI like a temporary, forgetful search engine are totally over. It is time to move beyond the amnesic AI and start building a permanent, evolving knowledge base that actually grows right alongside you. Your data stays on your own computer in plain text files that you completely own. So, I want to leave you with this provocative thought. What will your very first LLM Wiki be about? Thank you so much for joining me for this explainer, and I seriously can't wait to see what you build.